Good day, professors and learners. Good day, aspiring coders and software engineers. I am Herminio Ligon Jr., a senior student of the Master of Information System MIS under the University of the Philippines Open University. So this is my ID. Okay. So today I will talk about compilation and interpretation as concepts under the principles of programming languages. Okay, so before diving into the said concepts, let me define first what is a programming language. A programming language is a system of signs to communicate a task or algorithm to a computer, causing the task to be performed. It is any of various languages for expressing a set of detailed instructions for a digital computer. Programming languages are artificial languages in which the syntax and semantics are strictly defined. Thus, while they serve their purpose, they do not permit the freedom of expression that is a characteristic of a natural language. Some popular examples of this are JavaScript, Python, C, Java, and PHP. Now, the popular code example of a programming or a computer program is also the popular Hello World code, such as this code in Python and this one as the output. Now, on how the computer understands and executes this computer code or program is the very thing that we will unwrap today through the concepts of compilation and interpretation. Now, what is compilation? Compilation is defined as the process of translating source code written in a high-level programming language into a lower-level language, such as a machine code that can be executed by a computer. Simply put, a computer is basically unable to decipher and execute instruction if it is a high-level language, a language which is easily understandable by a human. Hence, it has to translate first the high-level language to a low-level language, such as an assembly language, and to machine language or binary code, which is basically 0 and 1 or electrical off and on before it can be executed as an instruction. Now, for compilation process to take place, a computer requires a special program called compiler. To illustrate you, let me show you the 6 steps on how a compiler works. The source code is a piece of code composed in a text editor, and the file extension for the source code is .c for C programming and .py for Python. Now, after this one is the pre-processing step. So this source code is initially transmitted to the preprocessor, which expands it. The enlarged code will be provided to the compiler after expansion. So next is the compiling. The code expanded by the preprocessor is passed to the compiler, this one, which converts it into assembly code. Next is the conversion into object code by an assembler. So, using an assembler, this one, the assembly code is transformed into object code, and then the object file created by an assembler has the same name as the source file. After is the linking. When a program occasionally references functions specified in other files, the linker serves, this one, the linker serves as a crucial role. In the compiler workflow, the primary function of a linker is to connect the object code of coding library data alongside the object code of a program. And then, the execution will follow. So the executable file, this one, is the final product of the linker, and it will be run through the computer as an output. I hope the concept of compilation is already clear to you now. Next, we will go to interpretation. Interpretation is defined as a method that simulates through a program running on another host computer, a computer whose machine language is a high-level language. It is basically as if the instructions of a high-level language is executed directly. Now, the software that executes the line-by-line conversion of the high-level instructions to machine-level programming is called interpreter. Although this sounds faster than compilation, the fact is, interpreted program runs slower than the compiled program. Why so? Since the program code is already converted into machine language in compiled program, its execution time is shortened. However, for interpreted program, the time required to interpret a full program is longer than the time needed by the compiler to accomplish its task because interpreters examine each line individually. To illustrate to you the all-in-one process of 4 functions under the interpreter, first function is the source code creation. So this step of the functionality is the same as in the case of compiler. During runtime, however, the interpreter transforms the source code one line at a time. Next is the direct interpretation. An interpreter meticulously translates a high-level language program into a machine-level language. Next is the source code editing. The interpreter permits program assessment and modification throughout the execution in a side-by-side window. And last but not the least is the execution. Compared to compiler, program execution is moderately sluggish since all the linking is done at the runtime without a separate linker. Now, head-to-head, if we compare compilation to interpretation, we can easily identify their main usage, including their strengths and weaknesses. For programming process, when using a compiler, the programming process is longer. In the interpreter, it's slower. For the purpose of the system, interpreter or compiler rather converts a whole program or code collection in one go. On the other hand, interpreter interprets a single line of code at a time, regardless of the number of lines or bundles in a program. For the speed of operation, a compiler typically accelerates program execution. Since the program code is already converted into machine language, its execution time is shortened. However, the time required to interpret a full program in interpreter is longer than the time needed by a compiler to accomplish each task because interpreters examine each line individually. For the applicability and use cases, a compiler is ideal for a production environment. To translate in these circumstances, programmers frequently employ compiled programming languages. And interpreters, these are ideal for a software development setting. For the sequence of program execution, when using a compiler, the execution of the program occurs autonomously from its compilation. Program execution happens only after the development of the entire program. Interpreters operate in different capacities. Parallel to the authoring of the source code, the process of running the program is carried out line by line in the course of the interpretation steps. For data capacity, due to the intermediate object code they generate, compilers typically require additional linkage, and this may demand more memory than interpreter-generated code. For interpreter, regarding data capacity, these are widely regarded as more effective than compilers because they do not generate immediate code, simplifying the entire procedure by decreasing the need for linkage. For error handling and debugging mechanism, compiler typically provides error messaging after examining every line of the program that it is attempting to translate. Although this can be useful for clustering errors, it can also increase the time required to debug and rectify programs, since the programmers must traverse every single piece of code. In contrast, interpreter addresses each error individually. This typically indicates that the interpreter can continue deciphering a program until an error is identified. For the amount of memory needed, a compiler needs more memory space since it creates an immediate object code. Object code is the binary code that is stored explicitly in a file. To store machine code, a compiler might want a separate memory source, such as disk storage. Meanwhile, an interpreter requires less memory due to the absence of intermediate object code. It seamlessly functions using just the computer's random access memory. For flexibility to make changes, utilizing a compiler can be challenging when modifying or altering a program code. For programs to undergo alteration, the source code as a whole must be modified. This makes using a compiler difficult. Comparatively, interpreters offer greater flexibility because they show errors one line at a time. This implies that the programmer can readily identify and eliminate translation errors. For the analysis of source code, the analysis of source code through a compiler requires considerable time, as previously discussed. An interpreter requires less time than a compiler to analyze source code. For the visibility into source code, with compiled languages, source code can be kept confidential. Executables do not contain source code, therefore, if you share your program with others, they cannot access your secret sauce. With an interpreter, anyone with whom you share your program will have access to its source code. And lastly, for the number of steps required, compiler, although both compiler and interpreters convert source code into machine-readable code, compilers require 2 steps. Before execution, a compiler converts the source code into a target program. On the other hand, interpreters accomplish this in a single step, which is simultaneously compiling and executing the program. So that's all. As a conclusion, regardless of whether you will use compilation method or interpretation method, the most important is it satisfies much of the key factors, such as the purpose of your computer program and the complexity and flexibility associated with it. In choosing so, you must also consider in the mentioned key factors the fit with your current resources, which include equipment and talents. Considering all these factors, you will then have to determine if you will satisfy the target time to deliver, including the security of the sweet fruit of your hard work, which is your source code. So that's all for today. Thank you for watching and listening, and goodbye.